this happens. All right, so let's move into absolute value inequalities. Now, there are multiple different ways that you can solve absolute value inequalities, but for consistency's purposes, I teach it kind of like this, okay? So what I do is instead of this less than sign, this is read as the absolute value of x minus 3 is less than 7, I think of it like this. The absolute value of x minus 3 is equal to 7, right? So I'm going to, in typical absolute value fashion, drop the absolute value bars and set it equal to the positive and negative version of this, okay? So on the right, I get x equals 10, or I'm sorry, this is the left, right? I add 3 to both sides, here and here. I end up with x over here, and 7 plus 3 is 10. And then on the right, I'm adding 3 again. This time I get x equals negative 4. So what I like to do in these cases is I like to put them on my number line. So here's my negative 4, maybe here's 0, and then 10 will be way up here. All right, so I know so these are places, if I check them, these are places that equal 7. Now that's not exactly what I want here. I want less than 7. So I know that because this is less than, these two numbers are not included. So I'm going to circle my two numbers, okay? So now what I'm going to do is I'm going to check in each interval. So if my graph, right, is going to change, it's going to change at these places. So it's going to hold basically whether it's true or not true in each one of these intervals. So I'm going to take a test point in each one of these intervals and see where it's true and not true. So I just need to pick one point in each one of these intervals on my number line. So this is my negative 4 and my 10 break my number line into 3 pieces. So this is my testing. Let's test when x equals negative 6. So I'm looking to see if my inequality holds true. So my solutions are where my inequality is a true statement. So I have the absolute value of negative 6 minus 3 is less than 7. And I'm looking, is this true? So this actually becomes the absolute value of negative 9 is less than 7. And the absolute value of negative 9 is actually positive 9, which is not less than 7. So this is false. Right, so I'm going to write false up here so I don't think, right, this is not part of my solution here. All right, so let me test a number in between negative 4 and 10. So I want to test something in here. Well, whenever I come across x equals 0 in there, I usually try that because that's a nice, simple one to try. So when I plug in 0, I'm plugging it back into here. Then I have the absolute value of minus 3 is less than 7 because I have 0 minus 3. Here, this ends up simplifying to 3 is less than 7, and this is true. So this piece here is part of my solution. Okay? So now the last thing I can check is a number that's bigger than 10, so let me try 12 for instance. Right? I can pick any number bigger than 10, just not 10. Any number bigger. So I have the absolute value of 12 minus 3 is less than 7. I'm looking, is that true? And I get the absolute value of 9 is less than 7, which is a false statement, right? 9 is definitely larger than 7. So this is also false. So my inequality, right, when it's written like this, I can write it as an inequality as x is between 10 and negative 4. Now I don't use the equal signs because this original one didn't have the equal, right? So I'm not going to use them here. All right, so let's look at this other piece over here. I'm going to solve this like it's x plus 2 equals 9. So that gives me x plus 2 is 9, and x plus 2 is negative 9. So I'm going to have x equals 7, and x equals negative 11. A quick check shows me that these actually do work, right? Because these are sometimes absolute value do give me extraneous answers. So my number line then, so I have negative 11 out here. Maybe I'll put my 0 here, so my 7 should be a little closer. So this one, when I'm looking at my inequality, it's greater than or equal to 9. So that means that solutions that give me 9 are in fact usable in my equation. So that means that the 11 and the 7 will be included. So I'm going to fill those in so I don't forget. All right, so now I'm going to test a point in each interval. So I'm going to test something out here. Let's say I have negative 12 is a nice number. And so if I put in negative 12 here, back here, I get negative 12 plus 2, which is negative 10. And 10 is, because I take the absolute value of negative 10, 10 is greater than or equal to 9. So this is true out here. So I'm just going to put a t this time. So that means that this piece is a solution. All right, so now if I look at the 0 as my test point, I'm going to plug in 0 here because I'm just going to pick something easy between negative 11 and 7. If I really wanted to, I could use a half, but I'm going to pick what's easy. So I put in 0. 0 plus 2 is 2. Absolute value of 2 is still 2, which is not greater than or equal to 9. So this is false in here. All right, so now I'm going to choose a number bigger than 7. Maybe I'll just choose 10 because it's easy. So if I choose x is 10, then I get 10 plus 2, which is 12. Absolute value of 12 is still 12, and 12 is in fact larger than or equal to 9. So this is also true out here. So this is what my inequality looks like. And so I can write this as either, right, this has two sections, right? So if they're all together, then I can write it like this, right? X is between these two numbers. But this is two different pieces, so I can say that this piece would be x is greater than or equal to 7, and this piece would be x is less than or equal to negative 11. So I can put an or between them. So this is my solution here. All right, so that's absolute value. Again, if you need more practice with these, there's a lot of them. There's several of them in the book, and we will do some in lab as well.